Hello, welcome to the Autodesk Utilities session. My name is Pete Southwood. With me today I have Teresa Elliott and Arnab Ganguly. And what we're going to do is talk about solutions that help resolve real-world problems that utilities face day in, day out. Now we're going to do that via, obviously, this session, but it's going to be a mixture of discussion, PowerPoint, some live presentation, and we'll be also giving some examples of real-world customers. And at the end of this session, you'll have a greater understanding of exactly the solutions that Autodesk provides. Teresa, if you watch the news lately, you hear a lot about economic stimulus. In fact, it seems to be on the TV all the time. And it sounds like, in spite of current economic conditions, utilities are spending money on their infrastructure. Would you say this is a true statement?
Yes, and some of that spending is associated with the economic stimulus programs. An example of that is in the U.S., where the Recovery Act has targeted over $50 billion for smart grids, water treatment, and utility infrastructure renewal. Industry estimates are that this will create, in just the U.S. alone, over 500,000 new jobs, and many of those are engineers, planners, and designers.
So that's the estimates around infrastructure renewal. Can you give me some more specifics on other spending?
Well, sure. Gartner just released their industry update covering 10 industries, and they forecast that utility industry IT spend will grow the fastest out of those 10 industries covered. And that's over 6% growth rate in Europe alone, and that's over twice the growth rate of any other industry.
So question, why is that?
Well, they say it's because smart grids, water resources, and energy supplies are viewed as national and strategic issues. I think we would all agree with that. And spending on engineering solutions is an absolute necessity.
I heard that in China, a single utility is spending over 14 billion, and that's billion with a B, by the way, on new transmission to deliver remote generation to load centers. I also know to support that project, they just bought 250 seats of Autodesk software just to design the transmission towers and the structures. So what are some of the key challenges that our utility customers are facing that cause them to spend this enormous amount of money on infrastructure?
The first is their infrastructure, as we've just been talking about. Plain and simple, it's getting old, and it can't accommodate today's new paradigm of intelligent grids, distributed renewable solar and wind generators, demand response, and even plug-in hybrid vehicles. And a recent Black & Veatch study shows that most utilities report that less than half of their transmission and distribution infrastructure is still within its useful lifespan.
Well, and of course that leads to failures. And these failures, as we know, we've seen some of the reports on TV with pipes bursting in New York and so forth. These failures can be catastrophic and extremely costly to repair.
That's correct. And because of this, utilities are trying to get smarter about asset management and reliability-based preventative maintenance.
So would it be fair to say, Teresa, that all of these renewal projects require design productivity and innovation, as well as much more complete, accurate, and accessible infrastructure models?
They need better coordination with a variety of stakeholders, and that's the community, local agencies, and even other utilities. In fact, coordination and accountability will be demanded of agencies receiving government stimulus dollars.
So productivity and efficiency is even more important now because everyone's watching their budgets. Would you say that's correct?
That's right. They have to do more with less and be more productive, and at the same time they're worried about losing some of their workforce. And this workforce that they're losing are people with a lot of knowledge about processes and service area. And that knowledge loss can also slow down productivity.
And at the same time, utilities face continued pressure always to provide reliable, quality service.
And doesn't stop there. Even regulators and government agencies continue to pass more stringent reporting requirements for environmental and public safety programs, to name a few. And all of these require ready access to the latest infrastructure information. And frankly, a lot of utilities just can't get to that information quickly.
No, you're right. It sounds like infrastructure, productivity, efficiency, and service quality. And these three topics will resonate with, I would say, every single utility.
I would agree. Pete, what I would like to do now is talk about why Autodesk within the utility industry specifically. Utilities have to extend the accuracy, precision, and value of infrastructure information to design and manage water, wastewater, electric, and gas networks more efficiently and sustainably than ever before.
So let's stop there for a moment. Design is really significant to utilities. This is the entry point to the utility infrastructure modeling process. Efficient, standardized designs and design processes are critical to safe, reliable, and sustainable operations.
That's correct. And in order to address quality of service that we talked about earlier, they need to leverage that design information across the infrastructure lifecycle. And that lifecycle is design, build, operate, and maintain.
All of the challenges we just talked about, they all require design work and, in fact, increasingly complex design work. True statement?
That's correct. An intelligent grid project requires that the utility design their network down to the location of the smart metering devices at the customer site. And a water system renewal project requires detailed design of piping locations and connectivity, as well as up-to-date information on current asset status and condition. And new designers need standardized processes and intelligence built into these design tools.
It's incredibly important to note at this stage that we've got a number of existing utility customers that have an investment in AutoCAD-based solutions. They want to maximize that investment. They want to maximize on the training of their existing AutoCAD trained personnel. And the beauty here is that the existing user base is familiar to that AutoCAD environment.
So when we talk about utilities managing a more complete infrastructure model, what we really mean is an intelligent and comprehensive process of visualizing, simulating, and analyzing utility infrastructure assets. And because they're sharing this information across the life cycle of design, build, operate, and maintain, this helps to improve productivity, efficiency, and responsiveness.
And of course, more easily handle customer requests, more quickly respond to outages, important.
That's right.
And more effectively provide information for reporting and decision analysis. Absolutely. And where we want to focus today is on the distribution networks for utilities and that life cycle we've mentioned: design, build, operate, and maintain.
And I would like to start with design, if that's okay with you.
Yep, please do.
So a new service request comes in, and it might be coming in from an external agency, and they provide utilities with many types of data, and the utility has to consume and assess this data in order to begin that project. Sometimes these contractors provide data in CAD formats, but it could be in other formats too.
Like raster images, GPS coordinates, survey data, and there's a wealth of other formats too.
Right, all sorts of forms. And this data, along with the information that the utility already has, maybe about the service area or location information, must be aggregated. Also, another thing to think about here is this planning. This whole project could actually be coming from the utility itself, because when they go through their system and maintenance planning, they may identify a project that requires design.
But the big burning question is, how do you do this? The designer needs to consolidate data from external sources, we talked about that, and from the utility's internal systems also. There may be a wealth of information internally. And many complaints we hear from utilities regarding data and integration of accurate data comes from this stage. For example, experiencing data inaccuracies from multiple drafters or poor digitization. The need for a more intelligent design tool that understands attributes and attributes associated with design elements. Need a way to view and share design and mapping data without making a large investment. They're having difficulties incorporating geospatial data from multiple formats, looking at ways of geo-referencing the designs and easily distributing the information to other workflow applications, distributing information internally, externally, using websites, using map books, publishing information. Let's take a look at how Map3D aggregates the data. And in order to do that, I've got a colleague of mine, Arnab Ganguly. Arnab, can you explain, please?
Yep, thanks, Pete. So what we are looking at right now is the existing overhead electrical wires being pulled in from an infrastructure model. The first step for most projects is for the planner to pull together information from multiple sources to get a clear picture of the project area before doing their work. Now, Map3D is an ideal tool for this planning step, as you can see here. The planner can very easily pull in data from a variety of sources. First, we will use FTO to pull in building footprint information from a shapefile. Once the planner has the existing utility facilities and building footprints, to properly plan the new network in its real-world context, the planner is going to bring in some satellite imagery. To make sure that they have all the right easements, they will bring in parcel data from a local land department. And finally, information from the water utility, because crews are going to dig up the roads, and obviously the planner needs to know exactly where the existing pipes are so that they don't send the crew to dig up the wrong areas. Once the base map is ready, the planner has all the information that they would need to understand the project and its impact. So with this base map data and Map 3D, the planner is now ready to communicate requirements, within the utility with other departments, as well as coordinate with other utilities on the project. So the planner has effectively all the information that they need to understand and communicate project impact.
So there's more to this design than we talked about, though, Pete. There's some precision design necessary to really address productivity and integration, right?
Absolutely right. And as a matter of fact, Autodesk software helps improve design by automating steps to the design process, such as the ability to right-size equipment. Wow, what a concept. Having the right equipment to do the right job. Perform what-if scenarios and engineering analysis, create documentation and identify materials and costs for the project. Automate some of the processes, integrate to work management systems, and generate accurate bills of materials. These are all things that Autodesk Utility Design does extremely well. And why not do that first in the office, get the design right, the what-if scenario right first, before potentially expensive mistakes are made out in the field.
And that's right, that's for the electric utility, but on the water wastewater side, we also have AutoCAD Civil 3D for site assessment, trenching, and grading. And even at the water treatment facility, we have tools like AutoCAD MEP to help design that treatment facility a 3D model before they go into the field.
Absolutely. So let's discuss AUD and the incredible design functions within Autodesk Utility Design. Arnab, is it here? Can you discuss that with us, please?
Yes, thanks again, Pete. So the next step in the process is for the designer to lay out the new underground network. Today we're going to use Autodesk Utility Design to do this work. As you can see, it's a familiar AutoCAD user interface with utility-specific tools in the tool palette to facilitate layout. First, the designer adds a pad for the transformer to sit on. They then add the underground line serving these houses. Note that these are not just lines on the screen. These are conduits containing cables. There's intelligence in the design. So, we can just click on the transformer pad and see information about it. For example, the estimated costs and sizing data. The last thing the designer will do is to ensure that the transformer is properly sized to serve the new connections. Analysis like this is a great way to build intelligence into the system to help utilities that have experienced workers retiring and being replaced by less experienced staff to get up to speed and be productive quickly. So here on the left-hand side of the screen, we can see the sizing information for the transformer and that it is properly sized.
So Pete, let's talk briefly about visualization. Often designs and plans must be shared with internal and external stakeholders.
Absolutely correct. Sometimes they have to take this information, these designs, to the city planners or economic development agencies. Projects such as transmission corridors, community development projects have to be presented. In fact, information in a lot of cases needs to be presented to public meetings in the way of exhibits.
Autodesk software provides the capability to manage and visualize these designs with web collaboration and 3D visualization tools. The web collaboration products that we have are Autodesk MapGuide or Autodesk Topobase Web.
And let's not forget there are other visualization products in the way of Autodesk Land Explorer or Autodesk Navisworks.
For today, I say we move on to a very important step, and that is ensuring that the most important information for these designs get to the field.
Let's talk about build. Construction documentation, including designs, maps, bills of materials, and other data are distributed to the field. Autodesk software provides the capability to deliver this aggregated design and geospatial data in a format that can easily be accessed, annotated, and even redlined by the field and can generate maps for the construction documentation. As we mentioned before, we have products that provide very detailed project information out to the field. And when we talk about water, wastewater projects, often you are dealing with an engineering construction firm that works with the utility to complete these projects. Here I want to talk about AutoCAD Civil 3D. It is very important to have a design tool that can update projects and quickly get updated information out to the field with a comprehensive set of construction documentation. But Autodesk software gives field workers the ability to capture and save edits in the field for simple redlining and annotation. as well as for further inspection and approval for the system of record. Field products from Autodesk include Autodesk Design Review, Autodesk MapGuide Enterprise, or Autodesk Topobase Web.
Pete, I'm really glad you mentioned red lines, because my next question to you has to do with how they provide this design information, which often includes red lines, back to the records department. We hear so often utilities talk about as-built backlogs, these massive backlogs of information coming in from the field.
Quite simply, the answer is records. Well, let's elaborate on that, but before I do, let's talk about the backlogs. You've mentioned as-built backlogs. Some utilities, I'm not going to mention their names, it's quite alarming the amount of backlog they have. Well, Autodesk provides tools that help aggregate the data sent back to the utility from the field, such as red lines and survey data, as well as aggregate the data they already have within the records. Autodesk software can help reconcile the as-designed and as-built data into the system of record to quite simply update the infrastructure model for people that need that information. And the tools, the solutions that are used to help our utility customers to do that, quite simply, are AutoCAD Map 3D or Autodesk Topobase. Now, we've seen the workflow, how the data goes back into the system, this complete life cycle of the information. But how do we actually manage this data going through its complete life cycle? Arnab, Topobase, please explain.
Yep. Thanks, Pete, one more time. After the project is complete, the records group can use Topobase to incorporate as-built information back into the infrastructure model, directly leveraging the original design, given the fact that it's all based on AutoCAD. Typically, backlogs are a huge issue for utilities in this process, and creating the infrastructure model directly can drastically reduce these backlogs. First, you see the design information overlaid on top of the infrastructure model. Then we check the new assets into the model, and Topobase automatically recognizes what's new and adds them into the infrastructure model, applies the business rules to ensure data quality. Finally, once the infrastructure model is up to date, operations can do things like look at the schematic of what's happening underground. Here we see the configuration of the conduit. Now, this is a very important step in maintaining assets, because if you ever do have to do repair work, it is important to know exactly what's underground and precisely where it is.
Now let's talk about operate. We now have these as-builts reconciled into the infrastructure model, and these updates are now available for anyone within the utility. And this infrastructure data provides information that's useful for operations engineering, or maybe is even shared with asset management systems.
Absolutely correct. And now the utility has accurate information about the network. And goodness me, if there is, and when there is a service disruption, an event triggers a number of reactive, for example, customer phone calls, and active, for example, sensors in the network notifications, sensors and network SCADA systems.
And this can be as simple as a single service point location outage or leak, but it could also be more significant disruption of service over an entire area.
You're absolutely right again. And Autodesk provides visualization software that can help customer service or the control room access geographic location as well as asset information about the network. Our customers use our web-based utility solutions built upon Autodesk MapGuide. So I get it. We looked at the 4 primary areas. In fact, we only looked at 3 of them: design, build, operate. What's the 4th one, Teresa?
Maintain. So now we're in the maintenance and planning phase of this life cycle. And I think it's important to note that a change to the network can happen as a result of a service disruption like we just talked about, but it could also be the result of internal planning and maintenance activities.
Absolutely correct. And it's all around assessment. The designer consolidates data from external sources, we talked about that, and from the infrastructure model. This helps the project manager to determine how to move forward with a project. Autodesk software helps utilities improve the process to get this data in a base map and aggregate many data sources and formats. Assessing your information you have in front of you, integrating new information coming in from various data sources, and then making the determination about how to move forwards. Is it a repair and maintenance job to go restore services, or is this a larger project?
That's right, and that's when the field work comes in as well. So if it's a maintenance job, the field crews access changes for the maintenance work and perform system repairs or planned maintenance activities.
And these edits in the field, whether on paper, in a desktop application or web-enabled must be inspected and approved to reconcile the maintenance into a system of record. We've gone through the complete life cycle of our infrastructure: design, build, operate, maintain. Do you want to finish there?
Sure, but one thing I would like to bring up again is this system planning and maintenance planning.
Okay.
We really have talked about it a few times already, but the point I would like to make is this happens all along this life cycle. It's not just happening once.
No, absolutely correct. It's a continuous process. Now remember, all this asset information, these reports, the thematic information, queries, all of the infrastructure model in its whole glory that is aggregated, this data is used to help assess things like brand new service requests, from design straight through to the planning stage, planning for future projects that may come through, even reports to regulators or to stakeholders.
Let's talk about the Los Angeles Department of Water and Power. They're delivering reliable, safe water and electricity supplies to more than 4 million residents and businesses in the greater Los Angeles area. But by the 1980s, the system's age and size were taking a toll on water service staff and those of other municipal agencies as well. So fire, police, and gas, they all had to deal with these huge paper maps to pinpoint locations of critical infrastructure.
And that was their biggest challenge. They faced the challenge of manually maintaining their infrastructure data, and they've been doing this since the mid-1980s. And this meant a growing strain on the budgets for staff and training as the city grew to become more densely populated. Employees spent most of their days updating designs manually and distributing maps on demand. The answer was an Autodesk suite of software solutions that is bringing Los Angeles' vital water infrastructure into the digital age.
And they chose AutoCAD Map 3D because it allowed them to better utilize this AutoCAD-trained workforce that they had. And they could also provide engineers with direct access to data and improve decisions with analysis and visualization tools. But there was more. They could support design and as-built data flow to GIS, asset management, and other applications, and improve sharing between engineering and all of the stakeholders within the utility.
Absolutely correct. And they did this with Map 3D because this software is a better AutoCAD for utility. Anchorage Municipal Light and Power turned to Autodesk, and specifically Autodesk Utility Design, to solve its unique challenges. For them, it wasn't just about design productivity and doing more with less. It was also about doing more with less experienced staff. In this environment, bringing new designers and engineers up to speed quickly is critical.
With Autodesk Utility Design, ML&P is able to improve design accuracy by reducing data errors. And they do this with standardization and processes that all of the designers can follow. They can complete tasks faster, in 3 hours rather than in 3 days, and empower the staff to be more productive. They can focus on the important tasks rather than manually entering the same data multiple times. And this ultimately improves service to the customer.
And they're able to achieve this because of the ability of utility design to build that intelligence into the designs and automate the process.
The city of Beloit, Wisconsin. With so many stakeholders, it's often not uncommon for a project to be 2/3 of the way done and then suddenly things change. So the schedule changes, the time frame, the scope of work. And what the city's engineering division needed was to be able to respond quickly to those changes, and they needed civil engineering software that can react as quickly as they do. And they chose AutoCAD Civil 3D because they believed it would make them more efficient and more productive and responsive to these field teams.
So what you're saying is AutoCAD Civil 3D software gave the city of Beloit the dexterity to accommodate changing project priorities and schedules.
Absolutely.
During Arnab's presentation at Topobase, we alluded to backlog of work requests, and that's a common problem with a number of utilities around the world. But a great example of a utility that really embraced an Autodesk solution like Topobase to actually integrate their design with their asset management data is the Las Vegas Valley Water District. They had over 3 years worth of backlog of requests, and it turned out that very roughly 25% of their existing GIS staff, their time, was used just fixing data errors. And of course that resulted in an incredibly high system maintenance cost. Now they chose Topobase and they chose Autodesk to supply to Topobase because of the number of very good benefits, but open, flexible architecture, very easy to integrate and connect to their incumbent proprietary systems. Infrastructure design and management, they wanted that in a single environment. That's exactly what Topobase gives. And they wanted a single source of truth.
Some of the benefits or some of the gains that they saw as a result of this was eliminating their project backlog, which was huge, being able to complete projects about 20% faster, and then reducing that data correction by about 15%. And this resulted in about $460,000 worth of annual data management savings for the company. And Jonathan Pickus, the manager of the AMFM GIS division, told us that Autodesk Topobase complements our existing enterprise systems, including ESRI, ArcSDE, and allows linkages with Hansen Asset Management and PeopleSoft with a single interface. So within a 5-month period, they were able to incorporate the software into their system from start to finish.
The City of St. Paul Department of Public Works in Minnesota is a mid-sized utility facing all of the challenges we described earlier. Their sewer lines are over 100 years old in many places. They are losing experienced workers, and their customers are demanding better service coordination. And just a few years ago, the department had all of their network information on more than 2,500 paper network maps. While these maps were accurate, they lacked the precision inherent in CAD drawings, and they were not easily accessed beyond a few everyday users with specialized knowledge. Now, using Autodesk's infrastructure modeling solutions, including AutoCAD, AutoCAD Map 3D, and Topobase, the department has one up-to-date and accurate source of data for designing, planning, and operating, and they can easily distribute project information. One great example, the city has a residential street vitality program, RSVP, to revitalize neighborhood streets across the city. With a complete infrastructure modeling solution, the water utility can coordinate much more effectively with the streets department and the gas company as they replace their lead connections and old mains in sync with other city projects. This type of efficiency in reporting and analysis is critical as the city looks for stimulus dollars and other funding sources for projects like this. Let's summarize this.
Okay, well, first, Autodesk Design Technology will help to improve how our nation's water utilities get updated and managed, and also help to effectively update aging water infrastructure and to support urbanization. Second, Autodesk Technology will help to improve how our electric and gas utilities provide and manage sustainable generation, address grid modernization, and intelligent grid initiatives.
And let's not forget, Autodesk Utility Solutions make it easier to consolidate and share accurate model-based design information to improve productivity. We're all after that. But also improve efficiency, improve responsiveness.
That's correct. And only Autodesk model-based utility solutions provide the ability to leverage this precision design across the entire asset lifecycle. So Pete, I have one more thing before we finish. The Autodesk Assistance Program is a way to help displaced AutoCAD professionals to update their skills and improve their employability through free training and discounted professional certification. To see if you qualify for this program and to get started, go to www.autodesk.com/assistance.
Thank you, Teresa. Thank you for joining us today. We have been pleased to be able to show you the solutions available from Autodesk for utility organization. If you should have some further questions in the future,